Tim Delesio. I am the CTO here at Techolution, and I have an exciting event sourcing topic for you as part of our Tech Talk series here. Let's start with, what is event sourcing? I think it's a very popular framework. It's used a lot in financial services, and I'm sure you've heard about it, especially if you're in the financial services industry. So let's just talk generally about what it is, why it's so important there, and why we should implement it. So before we begin, let's at least define what that is. And event sourcing is really just treat everything that goes into your system as immutable events. And if you don't know what immutable means, it essentially means the state can't be changed. So, like matter, it's created once, it cannot be destroyed. Same thing with events. As we create them, they live forever and are part of the system. Think of you want smart endpoints and dumb pipes. So the things that you do on the sides are really smart and get the job done. The thing in the middle just gets the data there. So that's really the essence of event sourcing. And to really make this work, you need to make sure that you have some sort of contract. Something that the person who's publishing the events and the subscriber who's receiving it, they agree on what that format's going to look like. The most successful ones I've seen either use Protobuf or Avro, which have a little bit more strict controls around the schema of what the object looks like. That way you can version it, control it, that kind of thing. You can use things like JSON, but that's a little bit more free. It doesn't kind of give you that overall visibility and control into your environment. The other kind of natural thing that goes with this is that all the communication is asynchronous. And when you have these events, really anybody at any time can pick up and subscribe to these events. So, the best way I think is going over an example here. So I have an example up here for you. I picked an example in financial services that everybody can relate to, but essentially this is the case study or the use case of someone canceling their credit card. Whether that be calling up through the phone or going online and doing it, there's some sort of user interaction that kicks this whole process off. They go into the website, they initiate that request through the form, they submit it, and that's where your first event comes through. So that system that picks up all that information, formats it, puts it in a format that's acceptable, that's part of the contract that we just talked about, and then pushes this into some sort of system that will then transmit that event. Kafka is a very popular technology in this space. It's an open source project that can, and I believe it was created by LinkedIn, and it's essentially almost infinitely scalable. I mean, you can scale this thing out crazy wide, and it'll handle the load. So that's why that solution is picked. It's open source. You can deploy it on any cloud that you want and leverage it. A lot of the cloud providers also have their own implementations that they run as managed services, but Kafka is a good one to choose, especially if you don't want any kind of vendor lock-in. So when you send that event for cancel credit card, you're going to have somebody listen to that event, subscribe to that event. And it could be one or many or as many really as you want for the security and allowing them to do it. And they can pick up things. So you may have an event that actually picks up and says, okay, we want to send an email to the user to let them know that we received their request. So that's just one person who listens to the event. We might have another event that will then update the system of record. And these are great for working with legacy systems, which I'll see in a second. But that will go in and it'll mark that saying, all right, this credit card is no longer active. We need to just let the system know that. So anybody else who works with it will get that information. And this event can then spawn multiple other events. So you can see the cascading effect here as you start to go through and create events and really start to frame together in an application that is reactive to events that are going on. So it's a very powerful design, and why should we implement this? And let's talk about that. So I think that's it seems good on paper, but there's a lot of drawbacks with this, and it is actually rather hard to do. So why do we go through this? Why what's our wins? What's the excitement for doing this? So the first and most important is it really breeds the concept of autonomous teams. So you want your teams to be autonomous, and if you're a very large institution with lots and lots of developers, thousands, tens of thousands, you need to be able to allow them some freedom, but still at the same time control what they do. So you want to give them a place where that they can go in and, create these new features, these new applications, but you got to do it in a way where you're not coupling and binding all your features together. So if you think more about like the monolithic world of mainframes and large WebSphere or WebLogic applications that exist out there that basically have everything baked in there, you need to break that up and start to get a hold of that and split it up. And this is a great way just to create that autonomy. So some of the things you really need to focus on with that though is that when you create your smart service that exists at the end of your dumb pipe, it has to be fully in control of all the input and output which you do. So when you release it and build it, you got to make sure that you have a very high test suite around it that you can test to make sure all the input and output are going in there, because you're not necessarily testing. I mean, you will eventually, but when you're designing it as a system as a whole, you're testing your small little endpoint that you're doing. So you need to make sure you have a high value, high control on that environment. Make sure all the input, all the output, all the edge cases, all the use cases are covered in your testing suite so that you're not breaking other people's expected results as you push data into or out of that service. But by doing that, you're essentially creating this team that just manages this feature, this subset of logic that you're doing, and it breeds this culture of autonomous teams that can function, essentially, as they want or as they need to. The next thing I mentioned earlier, immutability, right? That is, I like this graphic because it shows, the Zen power of immunity and what most application developers strive towards, right? You have a immutable class or object or something. You can trust that you don't have to worry about its state, right? You create it once, you push it in the system, it gets stored that way. It's that way forever. And now you can take those series of events and line them up and essentially rebuild your state. So it's a great way that you can take all the actions that occurred and you can find out that state of time no matter what. Think of the power of that. And this is, essentially how source code repositories work. Every change that you commit into the source code repository is an immutable change that went into the system. And now you can go back in time and you can look at any time you want to see what a change occurred, at what time, who did it, what, and essentially rebuild and put your system back to that state of where it was. So the same is true for immutable objects that are events. You can take them as a collection as a whole and rebuild the system of that environment. I mean, that's very powerful. That gives you the auditability. You can go and audit your system and say, okay, on this date, this time, what changes were in place and where? It gives you the ability to recreate problems. So if you have a problem in production and you want to be able to go in and see what the system looked like there, you can easily do that and go back to that state. So there's a lot of advantages, and this is why the immutability is so important, especially in financial services. The next reason why you should implement this is this is my graphic of fire and forget, right? So this is your asynchronous development aspect. You're essentially creating applications that aren't dependent on other people's changes. So in the realm of the monolith, and the opposite of this is obviously synchronous development. You're pushing for a request and you're waiting for whoever you're dependent on to respond to that request. So think of a web application where you're going in and you're updating a database. So that application, and this is the synchronous mode, will then go in and it'll open up a connection between the database, and it's going to sit there and wait for the database to respond. Once the database does its work and comes back, that operation frees back up and responds to it. Now, if you have a very high concurrent system where a lot of people are doing that same operation, you're eventually going to run out of connections. Connections are finite, because you're waiting for that database to fulfill the request and do the things that it needs to on the end. So this is, very powerful in the way that it can free up, and make things much faster. Because now you're just, instead of waiting, you're getting that request, boom, and you're firing it off. Getting the next request, boom, firing it off. So you're pushing all these systems into essentially a queue that these end systems can then manage them and run them as they need to. So this is where it works really well for financial institutions as well, because every bank or financial institution I've worked with always has some sort of mainframes. And I'm talking, things from the 60s, 70s, 80s, that are really running the business, that are irreplaceable in the business, and probably shouldn't be replaced at all, if not ever. And maybe one day when we get there, but these same systems were not built for high concurrency of what we have today. I mean, you can't throw 50, 100, 200,000 users at this thing and expect it to work. So by using this fire and forget asynchronous paradigm, you're essentially creating an artificial throttle in front of these systems. So as your modern systems pick up these requests, process them, they can push them onto a queue, and then the mainframes can pick them up at their speed and their capabilities. And you're not, cratering these systems and bringing them to their knees, because you're letting them operate at their own speed. And as they process them, they can handle them and then, take them off and shrink those queues and do all those fun things. Kind of the next item here, and this is a picture of an octopus hiding in the dirt. I love octopus. I think they're a fascinating creature. They change. They have all these they have essentially brains in their tentacles. Coolest animal ever. Anyway, I thought this was great because it goes into the how octopus adopt. How they, whatever environment they are, they can camouflage into it and adjust themselves. And I see this very significant, especially for the event sourcing world. So you have all these smart endpoints and dumb points, and at any time, somebody else can come in and subscribe to that event. I mean, just imagine the power of that. In the old way, you would have to go in and you'd have to recode that system to say, okay, now we need additional functionality for when somebody cancels their credit card, I want to do this too. But now you don't need to with event sourcing. You can just say, hey, I want that event too. And then I can subscribe to it, consume that data, and do what I want with it. This allows you to create an adaptive system that can do whatever you want without any changes to anything else. You just simply plug into the system, granted, assuming you have the authority to do so, and that's where the security comes in. But you just take that and you run with it, and you build off more events, and you can even have other people listen to your events. So it's a very adaptive system where you don't need to go in and regression test and make sure everything works the way it should. You're the master of your own domain here. You control your service. As long as that service works and operates, you're in the clear. So just a quick overview, why this is so cool, why this is so powerful, especially in financial services. You got your autonomous teams. You got them to create immutability with all the events that are going on, so you can replay, reconstruct, audit, view, and get an accurate state of things. Everything is asynchronous, so you get the additional capabilities of speed, no more bottlenecks. You can have integration with pretty much any legacy system you want through the use of adapters and facades. It plays very nice with the legacy technology, and it's extremely adaptive. I mean, all these things are really what future architectures are looking for. But I'd be, remiss here if I didn't talk about some of the drawbacks. I mean, this is hard stuff. Like, it's not simple. It takes a completely different mindset from the developers. I mean, most developers are stuck in this, synchronous world of, I'm sending a request. I got to wait till that request comes back. So it takes a bigger shift in mindset. It requires a tremendous amount of automation. I mean, there's a lot of room for error here. You're breaking your one application up into much smaller components. You need a way to be able to manage those components and do the same thing all the time. So, you need to be able to automate them in their build, their, scanning, their, all the aspects of your CI/CD pipeline, especially in your testing. You need automated testing, you need automated unit testing, you need automated integration testing. These are critical in order to get these systems to work. Without it, you're going to be creating a much harder landscape, and that kind of goes into my, it's harder to troubleshoot and manage these because, if something goes down and let's say there's, 6 events that are in a series that are manage a business process, if one doesn't work, you need to figure out why. Why didn't that work? Which part of those 6 went down? And so you need a way to essentially wrap holistically, for that business process to say where each of these systems work. They are also eventually consistent. So if you need an up to the date, and I'm talking to the millisecond or the second, representation of the world, this event sourcing is probably not for you. I mean, it does take time for events to be cleared from the queue. I mean, think of that legacy mainframe where they're picking up events whenever they want. That means that, when you submit the request, the system is not consistent across everywhere. It takes time. I mean, the consistency is guaranteed and it will be eventually consistent. But if you need that, real-time response to the world, then it's probably not going to be a good system for you. And if you need to rebuild, those systems, it does take a little bit of time to do that. It's, probably made it seem a little easier than it actually is to rebuild it, but you can do it. So with that, I hope you all go check out event sourcing. There's a lot of literature out there. You can always reach out to us. We specialize in this. We do a tremendous amount of event sourcing for our clients. So with that, I thank you for joining me, and I look forward to speaking to you again soon. Thanks.